Hi grade 12s, this is JP and we're going to be looking at annuities, the second part of the financial mathematics section. So we're going to do in part B, we're going to look at future value annuities, and in part C we're going to look at present value annuities. A lot of songs has been written on about money. We get Money Like This from ABBA, and then we get a little bit of a more controversial something like that, but that just scares you. But no songs that I know of has been written about annuities, which is very sad because they are so beautiful. So yeah, hopefully you're going to enjoy this. So we're going to just in this lesson focus on future value annuities.
Okay, let's look at the future value annuity formula. So we've got F as the subject of the equation, as of the formula, and that stands for the future value. That is a monetary value. In other words, what you're going to get after making regular payments after a series of time, after a specific time period. Okay, so that's the future value. X is regular payments, 1 plus I to the power of n. So n is the number of payments you're going to make. I is the interest rate divided by 100, that compounded interest rate. And then, so that's it. So what is an annuity? Okay, let's start there. So what's the difference between an annuity and just compound growth or simple growth? So annuity is when there's regular payments. It's not a lump sum amount of money that's just growing or depreciating. What happens now is there's regular payments that's been made, and each of those regular payments will attract interest, will gain interest. Okay, so let's look at an example. Okay, so let's look at this. So you don't need to now to derive this formula, but I think it will be very silly not to show you this. This is so beautiful. So what we're going to do is, remember, future value annuities is all to do with making regular payments. It's not like compound interest or simple interest that you've done in part A, where just a specific lump sum is just growing, right, or decreasing in value. What's happening now is, and the default is one time period from the present, is you are making regular payments into this annuity, all right? Regular payments. So X, you keep on making these regular payments into the annuity, okay? Keep on making it one, and when do we start? It's one time period from the present. So if T0 is the present, is right now, it's the end of this month, beginning of next month, right? And you keep on going, and the money is calculated when you make that last payment. Okay, so you keep on making regular payments. And we're going to do later is like what happens if you increase the value of the payment or decrease the value of the payment or skipping a payment. So that's all. Okay, so let's go for this. So what happens, of course, you're not just making payments into the account and nothing happens to those payments. Each of those payments will gather interest, right? Otherwise, you could just put the money under your pillow. That's the same logic thing. Each of those, that's why people have annuities, especially like future value annuities, retirement annuities, to make regular payments now and then to have a couple of bucks when they're a bit older, or if they need it somewhere later in life. So let's do this quickly. So what we've got, so each of these payments, like I said, will gather interest, right? So except for that last payment. So if we want to work out, okay, so that last payment is just that X. Okay, so let's make this one orange. That last payment is just X. The value is calculated, the future value is calculated as soon as that last payment is made. Okay, then the next one is, let's call this one X here. So that payment there at term 19, and I just use term 20 just to give you some perspective on it's 20 months that you've now made, you've paid into this account. Okay, so that payment at term 19 would generate interest for how long? For just that 1 month, right? Just for that 1 month, that payment that you've made at that specific time will generate interest. Okay, so that would be x 1 plus by I. Remember, it's like compound interest for that specific value, right? For that payment for 1 month. Okay, let's look at the next one. So this payment here, so that x value, how long will it generate interest? For 2 months, right? So plus by x, so compound growth for 2 months. Okay, and so you can go on. So say for example, it's not showing here, but say for example at term 17, what happens at term 17? Maybe if you're still unsure. So that's, you make a payment there. Oops. You make a payment at term 17, and how long will that generate interest? It will generate interest for 3 months, right? If we say, for example, N year is monthly, so for 3 months, and so we can go on. Okay, how long will the payment? So, for example, let's skip all the way back to term 3 now. Okay, how long will that generate interest? For how many months will the payment here generate interest? So how many months? So you're at term 3 now, all the way to term 20. How would you work that out? Yes, you would say it's for 17 months if you start at term 3 to term 20. So that's 17 months. But let's write this in terms of n. So for example, we don't know how many months there are. So that would have been n minus 3, right? If it was 30 payments you're going to make, so T30 was the last one, right? I'm sorry, if T30 was the last one, that part would have been 30 minus 3, right? And then we can continue. So the payment at T2, what would that be? So the payment here, so that part, that x there, so that would be x, sorry, that was 1 plus I, no? 1 plus I to the power of n minus 2. And then this part here, how many payments? 19, right? So it will, for 19 months, it will gather interest. So that would be, let's do this in blue. Let's do it in blue. So that would be x 1 plus I to the power of n minus 1. Right. And what do you get? You get a geometric sequence. Okay, beautiful. So our first term is equal to x, and our ratio is equal to 1 plus by I, and we don't know how many terms there are, so we're going to find the sum. So Sn is equal to a r to the n minus 1 over r minus 1. So Sn is equal to a, which is x, right, that first payment amount, and then you've got r, which is 1 plus I to the power of n minus 1 over r, which is 1 plus by I minus 1. And what do you do if you simplify? What happens if you simplify that? You get x 1 plus I to the power of n minus 1, and the 1 minus 1 is 0, so over I. Isn't that just too beautiful? And that's, of course, the same as that, right? You've got the sum of all the terms, so that will be the future value, right? Is equal to the number of regular installments you're going to make. That is the interest rate, right? 1 plus I, the compounded to each of those grow, right? And n is the number of periods at the time period, and over I, of course, the interest rate. Okay, again, you don't need to know how to derive the formula. It's not one of the proofs, but I do think this will give you a good idea about what is this all about. Let's quickly look at just 3 assumptions about the formula. The first one is that the first payment is made one time period from the present. So if you take out a future value annuity now, like a retirement fund, so you take it out now, the payment is made at the beginning of next month, right? Okay, so that's the first assumption for this formula. The second assumption is the time you're making that last payment, then the total value of your annuity is calculated. Do you follow? So that last payment won't generate any interest, okay, or accrue any interest. So then the very important part here is, this is the kind of logical, it's common sense, that the frequency of the interest must be the same as the payment frequency, right? So if you're going to make monthly payments, the interest must be calculated per monthly. It can't be per year then, right? And of course, remember, you can't just divide if it's per year, right? The effective is per year. You can't just divide that by 12, okay? Because we're going to look at later about the difference between nominal and effective interest. I think Claire touched on it, but I'll elaborate that in the next video. Okay, so those are the three assumptions. So the first payment, one time period from the present. Okay, so you don't pay immediately. So you take it out, and beginning of next month is your first payment. The total accumulated is calculated with that final payment is made. Your final payment is not gathering or accruing any interest, and then the interest frequency is equal to payment frequency per month, per term, per year, or whatever. Okay. What would happen if you're a bit haragad and say, listen now, I'm taking out a retirement annuity and I want you to take off money immediately now from my account, right? I want my first payment to be made immediately. Because remember, the default is one time period from the present. That just means you're going to increase the number of payments by 1. Okay, so it's not actually a big deal. So for example, if you would normally have made 20 payments, that now will be 21 payments. We're going to look at examples like that. So I'm going to look at the questions in your module on part B, because I think the easiest way to really understand this section, maybe some of you are just going like, I don't know what you're saying. Don't worry. Look at your module, and there's a couple of questions there. I think there's like eight or 9 questions, and I'm going to do each of those, but I want you to do it with me. So take out so have those modules, just have the question in front of you and do everything with me. You can also pause and just mark your work at the end, if that will be helpful to you. Let's look at question 1 there. So you'll notice that the characters in my story, John. John's a very popular person here, and John is going to make a number of investments and he's going to take out a number of loans. So let's check what John is doing here. Suppose John invests 500 Rand every month for the period of 8 months, starting 1 month from now. So that's default, right? So this question is straightforward. It's default Futurevalue. So we invest 500 Rand, regular payments per month. It's not just a lump sum money that's growing or depreciating. It's regular payments, 8 months, starting 1 month from now. His interest rate is 9% per annum compounded monthly, so that's the nominal interest rate. Calculate the value of his investment at the end of 8 months after he's made that 8th payment. Do you see, this is all default. Remember what we said earlier is the assumptions is that you make your first payment 1 period from the present, and the value accumulated is calculated as soon as that last payment is made. So do you understand? This is default. Okay, so what is the formula again? So so we've got it there. So future value is equal to the regular payments, and then it is 1 plus I to the power of n minus 1 over I. And now it's just substitution. All right. So the first part, if you don't know, that's what you want to work out. X, what is the regular payments he's making per month? It is 500 Rand per month. So that's that regular payment value. So then it is 1 plus I. And what is the interest rate here? The interest rate is 9% compounded monthly. All right. So that is okay. So what happens there? So that would be 9%, right? That is the rate over 100. So I, therefore, is going to be 9 over 100. So that will be 0.09. Okay, that makes sense. Now this is very important. It is compounded monthly. So what are you going to do? So how many months are there in a year, right? So that will be these 12 payments in a year, then 12 months in a year, right? And then what we're going to do is how many months are there in total? There are 8 months. So that is to the power of 8. Okay, minus 1. And then so I'll do that now. And then we've got 0.09 over 12 again. Because this is sometimes confused in the beginning. The rate, remember the rate payment, the frequency of the interest rate must be the same as the number of payments that's been made. So it's that 0.09, right? Monthly, so divided by 12, and okay, so that's how many, that's the interest rate then per month, right? In a way. And then this is how many payments, how many monthly payments there are. So those two things must just correspond, right? In months, or in years, or in per week. Okay. And then of course the same is on the bottom. So yeah, so once if you figure this all out, probably the most difficult part for you here is to understand what the hell this is. It is just your rate, so that 0.09, right? So 9%, 9 of 100, 0.09, and it is monthly, so divide by 12. Okay, so that's the big deal there. And what you do is you just type that in your calculator. That's not too bad, eh? You get something, the future value then of that annuity would be 4,106 Rand and 59 cents. Okay, so 500 Rand a month for 8 payments, right? And then 4,106 Rand, almost 60 cents is going to this John is going to get. Okay, so a very important part now. So how much money did interest give him? Okay, so how much money were accrued by interest? So what happens there is you've got 500, right? So that's the payments he's made. How many payments he's made? He's made 8. So that is equal to 4,000 Rand. But the future value is worth 4,106 Rand. So you've made 4,000 Rand in payments, right? And then he made 106 Rand and 59 cents he got from interest. Okay, so that's only after 8 months. Example 2 here, John opens a savings account for his daughter's future education. So, very noble. On opening the account, he deposits 850 Rand. Ooh, sneaky John. So he makes an immediate payment. Okay, remember the default is 1 time period from the present. John is harde, eh? He makes an immediate payment. That's good for you, John. Good. And then makes monthly payments of 850 Rand at the end of each month for the period of 10 years. So he's going to make regular payments. This is an annuity. All right, let's go for it. So what do we need to know? Okay, so his monthly payments is 850 Rand, okay? And then how many payments will he make? How many payments will he make? Well, he's going to make monthly payments for 10 years, so 10 times by 12, plus, because he's making that on opening the account, he so that's plus 1, the one that he shouldn't have by default made. So that is equal to 10 times by 12 plus 1 is equal to 121 payments, as opposed to 120 if he didn't make that first payment. Okay, and then what is the interest rate? The interest rate is 12% per annum compounded monthly. So I is going to be 12 divided by 100, right? So that's interest rate 12%, right? 12, so 0.12 over 12. Okay, there we go. Let's all substitute into now. So the first question there, calculate how much John will have accumulated at the end of 10 years. So future value is equal to x 1 plus I to the power of n minus 1 over I. So what will that be? So it's 850, and then you've got 1 plus 0.12 over 12 to the power of n. N is equal to 121 minus 1 over 0.12 divided by 12. And what is that equal to? That is going to equal to 198,338 Rand and 21 cents. All right? Good, John. That's not bad. She can go and study something. All right, and then the second part there is B, calculate how much interest was earned. So in other words, if he didn't substitute, deposit all those, the monthly payments into an annuity, if he dug a hole somewhere and just put the money in there, what's the difference between those two scenarios? Let's go for it. So the first one, so 850 made how many payments of 850? 121 of those. And what is 850 times by 121? It's 102,850 rand. Okay. And then, but how much is the investment worth in total? How much did the future value accumulate it? So that would be, in other words, there's 198,000, right? 189,000.
So what we've got is that, so the interest is going to be 198,338 rand and 21 cents minus that 102,850 rand of the regular payments that you've made. So how much interest did John get from his investment? It is 95,488 rand and 21 cents. Which is not shabby, eh? If you think of that, he's only made 102,000 rand worth of payments, and it's almost it's 95,000 rand of interest. Not too bad, eh?
Let's look at question 3. So his 25th birthday. So John, he wakes up and he says, "Hey, I want 5 million bucks on my 50th birthday to go and travel." He plans to make equal monthly payments in an account that pays 10% interest per annum, compounded monthly. If John makes his first payment a month after his 25th birthday, so that's by default, right? So it's his birthday, one time period after that, and his last payment is on his 50th birthday, so that's perfect. That's default, it's accumulated. The value accumulated is on that last payment. Determine how much you will need to deposit monthly. So now you know the value of the future. You have the future value, right? So you've got, you know what F is. F is equal to 5 million rand. And we want to know how much he needs to make those regular payments, right? He wants those regular payments to be the same. Let's look at what the interest rate is. The interest rate is 10% interest compounded per annum, compounded monthly. So that is that 10%, so that is 10 over 100, so that's 0.1, right? 0.10, 10 over 100. And then how many, at what interval monthly, so it's divided by 12, okay? Again, divide by 12. And how many payments will he make? Well, for 25 years, but the payments are made monthly, so it's 25 times by 12. And so that is equal to, 300, 300. So let's go for it. So we substitute that into the formula. So we've got F is equal to X, 1 plus I to the power of N minus 1 over I. So the future value is 5 million, right? He wants 5 million bucks. We don't know yet what X is. And then you've got 1 plus I, that is 0.1 over 12 to the power of N, so that is equal to 300 minus 1, that's a 1, over 0.1 over 12. Now your calculator skills are very important. I've always been amazed that people can WhatsApp without looking at their phones or send messages, but your calculator, some people just battle with their calculator. So just take out your calculator and put this all in. So you type that the part on the right hand side of the equation. Just don't type in the X there. You just type that all in your calculator, right? And you press equal, right? And then what you're going to do is you're going to store that, okay? And the store function is you press shift and you press the button above 7, okay? So it says store above that, the STO, and then you choose one of the A, B, C, D's in red. So say for example you press A, that stored it as answer A. Okay, so what you now just do is, okay, so you've got, in other words, you've got 5 million is equal to X times by whatever that A is. So A is going to be 5 million divided by A. Okay, that's that amount. You divide that on both sides. So you press alpha A, and there we go, and you press equal, and that is equal to 3,768 rand and 37 cents. Yeah, so that's the setup. So 5 million is equal to X times A, you divide A on both sides, So you get 3,768 Rand and 37 cents. And please don't be a numbnut and round off to 3 decimal place points. I mean, that makes it very difficult. It seems like there's 1,000 cents in a Rand. And, don't do that, please. Okay, let's consider question 4. John decides to start saving for an overseas trip to be taken to celebrate his 60th birthday. So John aged a bit now. Exactly 1 month after his 45th birthday, he starts to save a constant, regular payment, right, up to and including the payment made on the day of his 60th birthday. So it's between the 45th birthday, and it's a month later, and then the last one on his 60th birthday. Determine the amount that he needs to save each month in order to be able to withdraw 50,000 Rand on his 60th birthday, if the interest is 8.25% per annum, compounded monthly. Okay, so I want you to try this in here. You've got the formula now. It's very similar to that previous one we just did. See if you can do it yourself. Just pause the video quickly, and then after you've done it, then just mark your work. So pause the video now. Don't cheat. Pause. Hey, pause the video. I hear you. I can see you. Pause the video. Okay, let's look at the solution. So the future value, he wants 50,000 Rand to go and travel. So that's if. We don't know what the regular monthly payments are. That's what we want to find. How many months is going to pay? It's going to pay for 15 years, right? From his 45th birthday to 60th birthday. So 15 years, monthly payment. So that's equal to 180 payments that's going to be made. Okay, and what's the interest rate going to be? The I is going to be 8.25% annum compounded monthly. So it's 8.25 divided by 100. So that's 0.0825, right? And then monthly divided by 12. Okay, great. So let's go for it. So F is equal to X, 1 plus by I to the power of N minus 1 over I. So F is 50,000. X we want to work out. And then we've got 1 plus by I. I is this 0.0825 over 12 to the power of N. There's 180 payments minus 1 over I, which is 0.0825 over 12. Okay, same story now as we did in question 3. I would recommend that you save this part here, this what's done by X, all of this, right? Save that or store it as a memory, as a word of the memory function, and then just go 50,000 divided by that memory function. And if you do that, just check if you've done it right. X then is going to equal to 50,000 divided by all of that is going to equal to 141 Rand and 32 cents. So if he saves 141 Rand over 15 years per month, he will have 50,000 Rand to, I don't know, go on a hot air balloon ride or something in the land of Jonah. I would also recommend that you do question 5.